Our planet, the only known home of life in the universe, did not begin as a calm oasis. It began as a battlefield. A young, unstable world freshly forged from cosmic dust and molten stone, drifting around a newborn sun. Its surface glowed red-hot, its skies were thick with toxic gases, and for millions of years it endured a relentless barrage of asteroids that should have rendered it uninhabitable. But astonishingly, this violent era may have been exactly what transformed Earth into a world capable of hosting life. I'm Alex McColgan, and you're watching Astrum. Join me today as we uncover how a storm of cosmic destruction may have delivered the water, minerals, and molecular seeds that turned a hostile newborn Earth into the only living planet we know. To understand this story, we must travel back more than 4 billion years to the very beginning of our solar system. The Sun itself had only recently ignited, forming from a collapsing cloud of interstellar gas and dust. Around it circled a vast disk of rocky fragments, ice grains, and drifting gas currents twisting around the gravitational center. Over time, small pieces of debris collided and fused, forming planetesimals, cosmic building blocks that grew larger through their own gravity. Within only tens of millions of years, the terrestrial planets, including Earth, took shape out of this violent, swirling chaos. Their young surfaces were scorching hot, shaped by collisions with other early planetary fragments. One of these collisions was so immense that it ripped a chunk from the proto-Earth, flinging molten debris into orbit that would eventually cool and coalesce into our Moon. With time, Earth stabilized enough for its crust to cool and form a thin, fragile shell.
You might imagine that as planets grew larger and orbiting debris was cleared, cosmic impacts would naturally decrease. And indeed, for a while, they did. But something extraordinary happened roughly 4.1 billion years ago. Instead of tapering off, impacts surged again in an event scientists call the Late Heavy Bombardment. During a window of a few 100 million years, a blink in cosmic time, the Moon, and by extension Earth, were hammered by a catastrophic rain of asteroids. The evidence? Moon rocks returned by Apollo astronauts were nearly all dated to this same narrow window, suggesting a sudden spike, not random chance. Yet this discovery posed a deeper mystery. What could have triggered such a concentrated cosmic assault long after the planets had formed? To answer this, we must zoom out to a giant, Jupiter. The largest planet in our solar system possesses such immense gravity that it can rearrange the orbits of entire asteroid families. But Jupiter hasn't always been in its current position. Early in the solar system's history, Jupiter migrated inward toward the Sun, pulled by the remaining gas in the protoplanetary disk. Saturn later formed and did the same. Once both giants began interacting gravitationally, their combined pull reshaped everything around them. Their orbital resonance slingshotted Jupiter back outward, and this sudden shift destabilized millions of asteroids in the inner and outer solar system. Some were ejected entirely. Many more were aimed inward, directly toward Earth and the Moon. These asteroids came in two main types. S-type asteroids, made mostly of silicates and metals, originated from the inner solar system. C-type asteroids, darker and far richer in carbon and water, came from farther out. And it was precisely these water-rich asteroids that would change Earth forever.
As they fell onto Earth by the thousands, each one delivered not only minerals and metals, but also water locked inside their icy interiors. Today we know that Earth's water did not simply appear on its own. Much of it was delivered from space. But if this water had arrived earlier, when Earth's crust was still molten, it would have boiled away into space. The timing had to be perfect, and it was. By the start of the late heavy bombardment, Earth's surface had cooled enough to retain an atmosphere and trap incoming water, allowing oceans to form for the first time. Under the orange, toxic haze of Earth's young skies, water pooled in vast basins carved by impacts. Lava met ocean in explosive flashes of steam. Minerals brought by falling rocks dissolved into the water, forming chemical soups unlike anything on Earth today. Meanwhile, Earth's crust fractured under constant bombardment. Tectonic plates shifted rapidly. No craters remain today because the planet was too geologically active. They were erased by magma and movement. Only the moon, geologically quiet and airless, preserved the scars of this cosmic assault. But the bombardment provided more than water and minerals. Inside meteorites, scientists have discovered amino acids and the building blocks of DNA and RNA, complex organic molecules that could not easily form under early Earth conditions. Meteorites we see burn up today are too small to deliver such fragile molecules intact. But the massive asteroids of the late heavy bombardment were large enough to protect these compounds from total destruction. When they struck Earth, they delivered carbon, nitrogen, phosphorus, all essential ingredients for life.
After millions of years of devastation, something remarkable happened. The impacts slowed. Oceans deepened and stabilized. Atmosphere cooled enough for clouds, storms, and rainfall. Hydrothermal vents sprouted on ocean floors, pumping mineral-rich water into the seas. The chemistry of life had the conditions it needed, and astonishingly, fossil evidence suggests that life began almost immediately after the bombardment ended. The timing aligns too perfectly to ignore. It is as though the cosmic violence had prepared Earth, delivering everything necessary, stirring the oceans, supplying energy, and then stepping aside, leaving a world finally ready for biology. This raises an extraordinary possibility. Without the asteroid storm, Earth might never have become habitable. Without Jupiter's migration, the storm may never have happened. Without water-rich asteroids, our oceans might not exist. Without organic molecules from space, life's chemistry might never have begun. Destruction created creation. The moon preserves the only visible record of this epoch. Its surface is a fossil, untouched by weather, oceans, or plate tectonics. For this reason, scientists hope future missions such as Artemis will uncover deeper clues locked in ancient lunar rocks. These rocks may finally resolve debates about the bombardment's duration and intensity. Was it truly a sharp spike or a long, slow decline? Did Jupiter alone cause it, or were other gravitational interactions involved? Whatever the precise mechanism, one truth remains. Earth is what it is today because of this cosmic storm. Every river, every ocean, every drop of water you drink owes its existence to asteroids. Every metal we mine, nickel, copper, gold, likely arrived inside ancient impactors. And every living thing, including you, traces its existence back to the moment destruction delivered the ingredients for creation. Our world was forged in fire, shaped by chaos, baptized in oceans delivered from the sky. The asteroid storm did not just strike Earth, it built it. It made it alive.